and dividing rational expressions. We have done very similar things to this previously this year, so a lot of this will be review. So a couple things to remember. We can reduce common factors, but we can never reduce terms. We can change division into multiplication. That is the flip and multiply. And then we can reduce fractions vertically or diagonally by cross-reducing. We will show you that process once we get there. So let's start with number 1 here. So number 1, we have two fractions being multiplied. So let's go ahead and simplify our number of terms by multiplying the two fractions together. So I've got 5 times 27, which is 135. X squared times x to the 5th. Remember, multiplying like bases, we'll add our exponents. So 2 plus 5 gives me 7. And then I've just got y to the 3rd. All over 3 times 15, which is just 45. X times x to the 4th gives me x to the 5th. Y to the 4th times y gives me y to the 5th. So now I'm going to reduce my like terms. So 35 divided by 45, that simplifies as 3 over 1. Remember, when we are dividing exponents, it's the same as subtracting our exponents. So we've got 7 minus 5, which is going to give me x to the 2nd power. And then I've got 3 minus 5, which is going to give me y to the negative 2nd power. Now, the final thing I need to do is take the reciprocal of my negative exponent. So that's going to give me 3x squared over y squared, taking the reciprocal to make the exponent positive. All right, so let's keep going down with number 3 here. Once again, my first step is going to be to multiply my two fractions. So I've got 16 times 5, which is 80. 8 times 1, which is a. B cubed times 1, which is b cubed. And then I've got c minus 4. All over 25 times 12, which is 300. A squared times 1, b squared times 1, and then 4 minus c. So now what I'm going to do is I'm going to reduce my fractions. So 80 over 300, let's see. I could divide both of those terms by 20. So 80 divided by 20 is 4. 300 divided by 20 is 15. Now I'm going to simplify my variables here. So I've got 1 minus 2, just giving a to the negative 1st power. 3 minus 2, which gives me b to the 1st power, or just b. But now I'm trying to see, how can I take care of these two binomials here? So I think with a little bit of manipulation, we could actually make these equal to each other, since they share a lot of common terms. So one thing that I'm considering is, what if I was to multiply my bottom factor here by negative 1? So let's do a little side note here. So if I was to take negative 1 times negative 4 plus c, which is just my numerator here flipped around, that's going to give me, well, that's the same as saying c minus 4, which is my numerator. So looking at this, if I was to multiply my denominator by negative 1, I would get an equivalent statement to my numerator. So what I'm going to do is I'm going to make my whole fraction negative, and then I'm going to flip this around. So that's going to give me c minus 4 over negative 1 times this, which would flip my terms and would also give me c minus 4. We'll talk about this a little bit more in class together. So now I'm going to go ahead and simplify. So reducing my fractions, since these are common factors, I can reduce these by vertical reduction here. So that cancels those out. Over here, I have a negative exponent, so I'm going to take the reciprocal of that. So this is going to give me negative 4 over 15. A is in my denominator, and b is in my numerator. And that is my final answer there. All right, let's go to an example where we have to factor right away. So in a case like number 5, we have two trinomials plus a difference of squares. So the first thing I want to do is factor all three of my, my two trinomials and my binomial. I want to factor those and then see if I can use some cross reduction. So factoring my numerator here, this is a perfect square trinomial. So two numbers that multiply to 25 and add to 10 would give me 5 and 5. So my factors for my numerator are going to be x plus 5 times x plus 5. Then in my denominator here, I'm looking for two numbers that multiply to negative 15 and add to 2. That's going to give me positive 5 and negative 3. So I've got x plus 5, x minus 3. Sorry, not equals, multiplication there. And then I'm going to multiply that by my final term, x minus 3, which this is a difference of squares. My a value would be x. My b value, square root of 9, which is 3. So my two factors would be x minus 3, x plus 3 over 1, since this is not in a fraction to start. So now I'm going to go ahead and use some cross reduction. So in my denominator, I've got x plus 5, and in my numerator, I've got x plus 5. In my denominator, I've got x minus 3, same in my numerator, and I have no pairs with x plus 5 or x plus 3, so that's actually going to be my final solution. I've got x plus 5 times x plus 3. And that is my final solution for this one. So really, the key that we saw here in number 5 is that if you can factor, do it. Because many times you are going to find reductions that will allow you to simplify your fraction. All right, one more example here for the video. So in number 7, this is a division problem. So what's going on in number 7 here is we are taking our numerator, which is this fraction, divided by our denominator, which is another fraction. So remember, when we are dividing, that's the same as taking the reciprocal and multiplying. So I can rewrite this whole thing as 8x squared minus 72 over 5x plus 10 times 5x over 4x minus 2. All right. So the next step for this one is we have a lot going on. So I'm starting to take a look at some of these. And I just have a feeling that I could factor out a greatest common factor out of all three of these terms. Probably nothing I can do with 5x necessarily. So I'll just leave it for now. But a greatest common factor out of my numerator here could be 8. So if I was to factor out an 8, that's going to leave me with x squared minus 9, which is the difference of squares. In my denominator here, I could factor out a 5, which would leave me with 5 times x plus 2 times 5x, not a lot I can do there, over, I could factor out, wait, I'm forgetting a 1 there, 12. I could factor out a 4 then, which is nice. 4x minus 3. And then before I'm going to do reduction, I would like to simplify my x squared minus 9 since that is a difference of squares and it's fairly obvious. So I'm going to make that 8 times difference of squares. My a value is x. My b value is 3. So I've got x plus 3 times x minus 3 all over 5 times x plus 2 times 5x over 4 times x minus 3. All right, so we have done plenty of expanding here. Let's go ahead and start doing some canceling. So the first one that I noticed right away is we've got x minus 2, and I've got x minus 3. So I'm going to cancel x minus 3 and x minus 3. Cancel those out. The next thing I notice is I've got 5 times x, and I've got 5 times x plus 2. So I'm going to reduce those 5s. The final thing that I can reduce, that is a little more difficult to see, would be my 8 and my 4. So 8 divided by 4, that gives me 2, right? So I can just simplify this to be 2, canceling out my 4, which just helps me skip a step in the end here. So multiplying across my numerator, I've got 2 times x plus 3. So I'm going to write that as 2x times x plus 3 all over, and I've just got x plus 2 as my denominator. So that's actually going to be my final answer for this one. Okay, so I'm going to leave the rest of these examples for class. One little side note here is I know that these look quite overwhelming right away, but all of the skills that are needed in order to simplify these are things that we've already covered previously this year. So really, nothing here is new. It is just combining a lot of topics together. So if you feel like you have a certain reduction method that you are not very comfortable with, make sure that you practice that individually, and then you bring it to these type of problems. So we will most likely spend a couple of days working on these. So we'll do a couple of examples together the first day, maybe a couple the second day, and we will slowly pick these up. All right. Thank you all for watching. Please bring any questions that you have to class.